Hi, so today I will be presenting JoJoGAN one-shot face stylization. So, what is JoJoGAN and what is the goal of this procedure? So this is a procedure for learning a style mapper that applies some fixed style to input images. So as you can see here, this is what I mean by input images, and up here is what I mean by reference images. So the style mapper will apply a style. So these are the styles on one of these inputs. And then these here are the outputs. So it's kind of like a Snapchat image filter. So the goals of of this particular procedure compared to other ones that are similar, it is to be easy to use and produce high quality image results and require one style reference or allow users to control how much of the style gets transferred. So many other similar procedures to this one, they're either very difficult to use or the results aren't very good or they require or they require more style references. But JoJoGAN can use uh, either just a single style reference or multiple. So what kind of problem does JoJoGAN try to solve? So learning a style mapper is difficult because the natural method uses paired or unpaired image translation, and this is a very impractical, tedious process. And collecting a new data set for every style can be tedious, even the smaller ones. And there are some styles, they may not have many examples either. Like let's say maybe a famous painter, uh, he throughout his career maybe creates only 200 paintings. And this painter has like a distinct way of painting, like for example, like Picasso. And 200 may not be enough sometimes with other procedures. And but with JoJoGAN, it tries to combat that is to combat this issue. And also other similar procedures, they may use slower inversion processes. So these are some tools that were used in JoJoGAN that I will reference in the following slides. So JoJoGAN, what it does, it creates a paired data set from a single style reference by manipulating a pre-trained StyleGAN2 and a GAN inversion procedure. And then finally, it fine-tunes using the created data set. Excuse me. If you don't know what StyleGAN is, it's a state-of-the-art generative adversarial network that specializes in high-resolution image synthesis. And the kind of inversion that JoJoGAN uses is called a feed-forward inversion. And this kind of inversion that they use is based on a simple encoder. And then the following points are will be referenced in the following slide. They're operations. So basically, the T operation refers to GAN inversion operation. G refers to style GAN, and little s, means style parameters in style GAN's S space, and the theta here means it stands for the parameters of the vanilla style GAN. What method or approach is used for this procedure? So it uses 4 steps. So the first step is GAN inversion. So this is the reference image Y, and then we invert it with the t operation. Um, so w equals t of y, and then from this operation we get a set of s parameters s of w, and this code it results in realistic face images. So this is the inverted result. Uh, it looks a bit more realistic, more like it's a person wearing makeup rather than this image right here, where it's more like a cartoon. And just because the realistic face images occur because the there is no stylized faces viewed during the training. Step two. So step two is to create a training set. So little s right here is used to find a set of style codes S that are close to that are as close as possible to little s using StyleGAN. And then step three, we fine-tune StyleGAN. So StyleGAN is fine-tuned to obtain theta hat such that uh, the 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 StyleGAN operation is close to y, the reference image. And step four is to create an inference. So using the input u, so this is the input image u, and the results from the previous steps to produce the stylized face. So here I'll play this video I made about the demo of the code. Alright, so I will start this demo of the JoJoGAN one-shot face stylization. The quality of the video will improve in a second. Uh, so this is the GitHub page, and right here is how you access the Colab notebook. So okay, so here is the start, the setup. I've added this line right here and dash y right here. Um, Otherwise, you get errors like regarding installation. And I've already done this step because the demo has to be short. So yeah, so I've done the download and initialization. So here you download models, and I chose CUDA. And here you have the two options for the input face, or at least in the Google Colab. You have IU and Chris Hemsworth. So yeah, it takes some seconds. Okay, so here we have Chris Hemsworth, and to use pre-trained styles, so we have some um, some styles that the program is pre-trained with already. So we have Arcane, like from the TV show, and JoJo from the anime, and some other ones. Right now, I'll choose the Arcane one. And then this is a rather interesting feature, preserved color. So preserved color tries to preserve the color of the original image by limiting the family of allowable transformations. So say I have this unchecked, right? So the final image, the colors are going to be more similar to the stylized image. So I will show you. Let's see. I will demonstrate both with preserved color and no preserved color. So right now, okay. So this is the input and this is a reference. And then this is the output, the stylized image. And here we have the random samples. So here we listed 7 random samples, so that's what we have right here. And okay, so the colors here are more similar to the Jinx style photo. So what if I check it? So the colors now of the output are more similar to the input rather than the style image. So like you see the hair is black now. It's not blue anymore. Yeah. And then also the same thing for the random samples. And okay, I will demonstrate one other thing. Um, okay, so here we can, okay, so here is the sketch pre-trained model, the pre-trained images. So the reference image input and the output, and the random samples as well. So okay, I will address this later. So here we can train with our own style images as well. So the program works better if we have more style references. So before we had one, now we have these four. You see, one, two, three, four. And here is the fine-tuning step. So you can choose the number of iterations, and this takes like several minutes. So I've already done this. And the alpha controls the strength of the style. And here we generate the results. So after using these reference images and then this input, this is what the output will be for using this face. And then here is what the random samples will look like. All right, so that's the end of the demo. Let's see, next slide. All right, so I will start. So, results. So they made the authors of the paper, they created they set up some different types of evaluation, so qualitative and quantitative. So to begin, I'll start with the qualitative evaluation. So JoJoGAN captures what they saw with JoJoGAN is that it captured small details well that defined the style while maintaining the identity of the input image well. And traditionally, one-shot stylization, it copies effects from the style reference aggressively. So these are the style reference images, and then the input. Then right here is the output. And then when there are multiple style examples, JoJoGAN is able to blend details to appear more similar to the input. So okay, so JoJoGAN results are typically improved when there's multiple consistent style references. So as you can see here, these are the style references, and uh, um, they're consistent, right? They look like sketches. And then with this input and with all of these references, once you JoJoGAN, it produces this output image, which is more out of all of these is the most similar to the input out of these 5 images right here. If you use all these reference images together. So quantitative evaluation. So what they one of the quantitative evaluations that they used was a two-stage user study. So as you can see here, JoJoGAN is the one we're talking about right now. And then there's other similar procedures, DST, StyleGAN, NADA, BlendGAN, and this one done by Oja, and so yeah, so these are the results. It's a comparison of all the results, and so the DST it gives good results in most cases, while the other ones they have similar problems as you can see, and so in the first stage of the study, JoJoGAN is compared to the non-DST methods. So style GAN, blend GAN, and this one. And in the second stage, because DST is the one that is like the second best, JoJoGAN is compared to DST in the second stage. So a number of participants were used. They participated in each stage. So in the first stage, 186 responses from 31 participants. They overwhelmingly preferred the JoJoGAN model compared to the other methods. So these three, 80%. Then in the second stage, 96 responses from 16 participants. In the study comparing JoJoGAN to DST, they preferred JoJoGAN to DST at 74%. So comments. So this kind of project reminds me of like the the image filters you can see people use on social media. So maybe a procedure like this one can be used to improve the quality of the results from those filters. And also, it'd be interesting to see further experiments with inputs and reference images of non-face objects. So what I've shown throughout this presentation is mostly like face input, like inputs of people with faces and references, also faces. It'd be interesting to see like maybe f photos of other objects of like non-people objects. So maybe um yeah, it because at the beginning at towards like the start of the paper, they mentioned that it also works for other kinds of objects, not necessarily just people. So I'd like to see maybe more like comparison of results on of this style mapping procedure used on other kinds of objects. And also I'd like to see I think it'd be interesting to do more experiments with different kinds of extreme style references to test the limits of JoJoGAN because the authors they mentioned that the eye gaze direction is usually driven by the reference image rather than the input image. When the results they should depict the opposite. So for example, this photo right here, this person is looking straight, but in using this reference image, the reference is looking to the left, and then with this output right here, it should be facing straight, like towards yeah, the eye should be facing straight, but instead they're facing to the left. So yeah, I'd like to see more different kinds of extreme style references, such as these ones, like this one with the lines all over the face, and this one with like think puzzle pieces and pixels. And then these ones also count as extreme style reference because the styles they don't look human, they're animals. So these are the references right here. This is just the output. So the input of um of this actress here, and then the reference images, and then they map this reference to the input, and this is the output that gets that are the results in the from this procedure. And here are the references. So this is the the reference for the project paper and the GitHub, and then some of the references they use within this paper that I reference in some of the slides, like the information about StyleGAN and the inversion procedure. Yeah. So that this should be the end of my presentation.